and welcome to the inaugural video of the SOLIDWORKS Student Leadership Program at UCLA, or SLP at UCLA, here to teach you about SOLIDWORKS. The SOLIDWORKS Student Leader Program is officially constructed by Dassault Systems. Our main mission is to communicate information about SOLIDWORKS to students, including certification programs and other available resources. Check out our website and join our Slack channel if you're a UCLA student. Links in the description. In this video series, we will take you step by step through all of the challenges and intricacies of the CSWA test so that you will pass with flying colors when the time comes. But what is the CSWA test? And more importantly, why should you take it? Well, CSWA stands for Certified SOLIDWORKS Associate. This means that if you take and pass the test, Dassault Systems will send you an official certificate saying that you know how to use SOLIDWORKS. As you might expect, this looks great on resumes. Since only less than 10% of SOLIDWORKS users are certified, you will also be joining an exclusive club of SOLIDWORKS aficionados. In this video, we will look at SOLIDWORKS drawings. The CSWA has two parts, a multiple choice section and a free response section. On the multiple choice section, you will be asked to identify certain drawing features given a screenshot. On the free response section, you will be asked to create parts from drawings that will be given to you. The multiple choice section holds less points than the parts section, but are quicker to do and are straightforward. Today, we will be addressing drawing features that you may need to identify on both the multiple choice and the free response sections. So let's dive right into it.
Thank you, Willy, for that introduction. So now we're going to be actually getting into a pre-made drawing and explaining the drawing views that are in it. So if you want to follow along with us on your own computer, we have the drawing and part available in the description down below, so you can go ahead and download that and follow along. So the part that we're going to be investigating today via the drawing is this part. So it's a pretty complicated part. It's got a bunch of different features, but essentially you have this very long cylinder that's protruding out from the part on this side. Then you have a kind of a hexagon connecting that cylinder to this main block over here. This main block is basically a cube, but it's got an angled face on this side. And on the angled face you can see a pin and two holes. Then on the other side of that kind of cube block you have a partially open cylinder with a cap on it. So that's kind of a high-level overview of what this part entailed. But on the CSWA, it's kind of interesting to note is that you only be tested on a specific subset of drawing views that you could actually create on a drawing. So a drawing is created from a part, right? And a drawing is very useful if you're going to have your part manufactured. So you give a drawing to your manufacturing plant, and they will be able to create your part in real life from that drawing. So SOLIDWORKS provides a bunch of different drawing views, but the ones that the CSWA is going to be focusing on are the model view, projected view, auxiliary view, section view, remove section, detailed view, broken out section, break view, and crop view. So these are the ones that are most likely going to be tested on the CSWA. So we'll be going each of these in turn, so by the time you take the test, you'll know exactly which feature they're going to be asking about. So let's go ahead and switch over to the drawing, which was created from this part. And so yeah, here's the drawing. So the very first view that you're going to insert into your drawing usually is called a model view. So this is kind of the base view from which all the other views are derived. In this case, our model view is the bottom left-hand corner. We inserted kind of a side view, so this is our model view. And from that model view, you can get projected views. So in the top left here, we have a projected view of the model from kind of viewed from the side on the cap, right? You can see the cap. And then in the bottom right-hand corner, you can see kind of 180 degrees actually of this view. So these are called projected views. In the upper right-hand corner, we have the isometric view. So personally, my model view is actually going to be an isometric view because from the isometric view, you can get many different projected views, right? But in this case, we just decided to go with this as our model view. Oops, sorry. We just decided to go with that as our model view. And yeah, but you can basically put in any view as your model view and create projected views from that. So next, The next view that we're going to be discussing today is called the auxiliary view. So the auxiliary view is very useful if you want to see what an angled face looks like, or what features are on an angled face. So as discussed before, we have this cube, right? But then this cube has one angled face on the side of it. And how do you see what's on that angled face? Well, you can use the auxiliary view. And you can see in the to the upper right of it, you can see down on that angled face. So you can see that the pin is there and the two holes are also there. Next is the section view. This is quite a simple view to understand. It's basically taking a plane, cutting it through the part, splitting it into two, and you can basically see what's inside. So it's useful if you have details on the inside of a part that are quite intricate or you're not able to see from the outside. So you can see we just took a plane through the center of this, and then here we have part of the section view on the upper left of it. So this is what it looks like on the inside. Next we have the removed section. So removed section allows you to see what a part looks like on the inside at specific points or at specific planes. So you can see that we just took a plane here and a plane here, cut it at those points, and then what it looks like on the inside at this point is a hexagon. So you can kind of see this dashed line. It's all the way over here. So it looks like a hexagon, and then over here on this plane it looks like a circle on the inside. So that's a removed section. Next is a detail view. You'll be seeing these a lot. A detail view allows you to zoom in on a specific section of the part. It's really useful if you have really small features or really small dimensions, really small things that you're working with on your part that you won't be able to see in the regular scale of your drawing. So a detail view will specify the scale. So in the bottom we see that's a scale of 1:1, meaning that if you printed out this drawing and you looked at this view, that would actually be the same dimensions physically as your manufactured part would be. So it kind of gives you a detailed view of the features on a specific section of the part. In this case, we've zoomed in on the pin and the two holes, so you can kind of see it in more detail. Next is the broken out section. So the broken out section is kind of interesting. It allows you to cut away a selected section of a part while leaving behind the outside surface for reference. So this is useful if you want to kind of maintain your reference of an outside surface. So in this case, we have a broken out section applied to this view. So you can see the inside of the part, but you can also see the outside of the part. So it's kind of an interesting view in that regard. Next we have the break view. This is really useful if you have a really long part that may not necessarily fit on your drawing. So in this case we have the break view. It's indicated by these two jagged lines here. And you may remember that the part is very long, right, because it has this very long cylinder. But using the break view, we can actually just cut out the middle part of that cylinder, leaving behind a much shortened view that fits better on a drawing. And last we have the crop view. So the crop view is also pretty useful. It allows you to cut away everything that you don't specify. It allows you to focus in on a specific section of a view. So in this case, we took a crop view to actually a section view, and you may remember the section view actually takes a plane, cuts a part in two, and allows you to see the inside. But if you took a section view on this plane, you would get the entire length of the part, which is very long. So we actually took a crop view to that, so you can only see the circle. So again, it's good for spacing, but it's also good for focusing on specific things that you want whoever is manufacturing the part to focus in on. So yeah, this has been a quick overview of the different drawing views that you may be tested on the CSWA, and I'm going to pass it on to the next presenter.
Thank you, Abe, for that fabulous description of all those specific drawing views. That'll be very helpful when we're taking the test. Now we're going to talk about how drawings are going to be used in the next part of the test, which will be making parts based off of drawings. So we've discussed how you can make a drawing off of a part, and what views to make, what views to use when making those parts. But now we're going to talk about how to make a part off of the drawing. So as you can see here, we have this part here, and it looks like a little door hinge. And this is a part that they would expect you to be able to make in the CSWA exam. So let's go over the parts of this drawing here that are going to be important for you to consider when you're making the part on the test. So let's start off with the dimensions. So the dimensions, which may be a little self-explanatory, are these these numbers all across the drawing, and they're just going to give you the size of everything in millimeters. So like the circle will have a dimension of 12 millimeters in diameter. This dimension here between the top and bottom here is gonna be 15, right? And these will be all across the drawings, and these are going to be the main way you're going to make your part. And then, as you can see here, if this is a little important, they're trying to trick you here with this slot. Since there's this R, they're not talking about the diameter anymore. They're talking about the radius, right? R for radius. So you're gonna have to multiply this by 2 to get the diameter, which is the number you have to put in when you're making the part. And so the diameter here is going to be 15, right? Not 7.5. Next up, we've got the views that they're using in this drawing, and this is actually very helpful for you to be able to make this part easier. You've got this section view, like Abe was talking about in the last part. This section view is this face here. It's like normal to that face. We've cut off this top part, so you don't have to deal with that, right? This weird overhang is not obstructing your view of these holes. We've got the obviously the isometric view, which usually does not have any dimensions associated with it. It's just the best view that you can get, like the best angle of the part that you are describing. Let's see, we got a auxiliary view over here. We've got this face, right, is this auxiliary view, and this is mostly used for this cutout here, this hole extrude, and this is telling you that this is going to be a cylinder or a semi-cylinder, and not just like a square, which may be what it looks like in this part or this part. Those are the helpful views that you're going to get, and some parts may have more views and some parts may have less, depending on the complexity of the part. Next, we're going to look at some of the features, and again, some of these features that you're going to have to know how to do are going to be like, this is a fillet here, right? And we can find the dimension of this fillet as look, here's the R again, radius of 2. Fortunately for fillets, you're already inputting the radius, so this is not trying to trick you at all. This radius is 2, and it goes all the way along this edge, so we know that the top and bottom of these holes are filleted. Some other things, these will be hole extrusions, just regular extrusions for like this 3D part. You might have to make this side view, extrude that, and then make like holes or extra sketches to make this cylinder, for example. And finally, we're going to talk about these variables down here. You may have been wondering about those. So variables are actually very important for when you're doing the CSWA exam, because that's how they're going to test your part in multiple different questions. For example, they will give you these numbers for question 1, and then they'll have you keep the same exact part, only changing these variables, right? So instead of A being equal to 100 over here, A is going to be equal to maybe 150 in the next question, right? And B will be something else, and C will be something else. And so variables are really important because they'll be able to let you know which things you're going to have to change and which global variables you're going to have to make to efficiently create all your parts. All right, that's it for us. I hope you enjoy the video and you learned something helpful. Please come back and watch the next video in the series. We should be creating a part based on a drawing. So we'll be taking you through step by step how to make a part for the CSWA exam. And again, if you're interested in taking the CSWA test, or you're just interested in what we do here at SLP, feel free to look at the website and the Slack channel down in the description. All right, thank you and have a great day.